All right, today, model with function combination. So we are taking functions and figuring out how to combine them to solve problems. Owner is participating in a walkathon fundraiser. 2 donors promise to donate money based on the total distance he walks. The money A in dollars that he receives from the first donor, that given that he walks D kilometers, is given by the formula A of D equals 10D. The money B in dollars that he receives from the second donor, given that he walks D kilometers, is given by the formula B of D equals 2D plus D squared. Let T be the total money that owner raises from these donors by walking D kilometers in a walkathon. Write a formula for T of D in terms of A of D plus B of D. So if we take a look at here, right, what do we have? We had T right here. This is my total. And how do you find a total of something? You add things. What am I adding? I'm adding the money from the first donor plus the money from the second donor. So when it says in terms of A and D and B of D, that's what it wants me to have inside here. So it says my total T of D equals, well, it's just going to be A of D. I need parentheses here. A of D plus B of D. Make sure capitals and small letters, make sure you're using the right variables, or else Khan Academy's going to throw a fit. Don't want that to happen. Now then it says write a formula for T of D in terms of D. So all I do is I replace A of D. Replace A of D with what A of D equals. And A of D equals 10D. So I'll go, okay, I'm replacing A of D with 10D. And I'm going to replace B of D with what B of D equals. And B of D equals 2D plus D squared. This will be plus 2D plus 2D plus D squared. Then I just need to simplify this. 10D plus 2D is 12D plus D squared. So that's what should be in this box down here. 12D plus D squared. Ah, I forgot my D. 12D plus D squared. Always helps when you type in the right answer, right? Silly me. Well, we got another one. Scarlett sells designer ponchos. The revenue R she makes from selling N ponchos is given by the function R of N, which equals 20N. And the expenses that she incurs from producing a batch of N ponchos is given by the function E of N, which equals 10 times the square root of N. Let P be the total profit from producing and selling a batch of N ponchos. Write a formula P of N in terms of R of N and E of N. So profit, right? Profit always equals revenue minus expenses. So my revenue is R of N, and my expenses is E of N. All right? So R of N minus E of N should go right in here. Parentheses, having trouble with that today. Good thing I caught it this time though. R of N minus E of N. E of N. Then it says write it in terms of N, so I'm just going to replace R of N with 20N minus, I'm going to replace E of N with 10 times the square root of N. We don't have to put that times symbol there. If you want to, you can, but we don't have to. There's no simplification to be done because this is inside a square root, this is outside a square root. They don't talk to each other because this one's in prison, this one's not in prison. So it should just be 20N, hey, remember my variable this time, minus 10 square root SQRT of N. Boom. Next one, the distance that Amelia runs each day depends on the number of hours H that she works. The distance D in miles and the time T in minutes that she runs are given by the functions D of H equals negative 0.5H plus 9.5 and T of H equals negative 5.5H plus 92.5 respectively. Let R be the average speed that Amelia runs on a day in which she works H hours. It really helps if I know this equation right here. Distance equals rate times time. And we want to find rate, which is her speed, right? So we want to get r by itself. T stopping me. This is r times t. To get rid of a times, we divide both sides by t. So that'll go away. And so I get the equation r equals distance over time. So d of h is my distance. T of h is my time. So I'm just going to go distance, d of h, divided by time, t of h. And then it says, write a formula in terms of h. So again, I'm just going to replace d of h with negative 0.5 h plus 9.5. And I will replace t of h with negative 5.5 h plus 92.5. And I could do some simplification here. I'm not going to do it. This is beyond us right now. So I'm just going to type parentheses for the top, negative 0.5 h plus 9.5. That's for the top. Divided by, for the bottom, negative 5.5 h plus 92.5. Okay? And I got it right. If all goes according to plan, the function a of t equals 200 times 1.1 to the t power will model the amount of potatoes, A, in bushels produced by Burian's farm t years from now. And the function r of t equals 5,000 times 1.11 to the t power will model the revenue in dollars earned from selling these potatoes. Let P be the proposed price of a single bushel of potatoes t years from now. Write a formula for P of t in terms of A of t and R of t. So let's think about this. Here's his number of potatoes he's making. This is his revenue for the farm, for the whole farm, all the potatoes he sells. I want to know the price of a single bushel of potatoes. Right, so how do I do that? I take the price of potatoes and divide it by how many potatoes I'm selling, right? That's how I find the price of one potato, or one bushel of potatoes, I should say. So what's my price of potatoes? What's the cost of my potatoes? What is my revenue of potatoes? I'm bringing in this for my revenue. So this will be R of t over number of potatoes. This is the amount of potatoes he's selling, over, well, in this case, I want me to do it in terms of R of t and A of t, over A of t. Just put that in there, R of t over A of t. Okay. Don't know why it's not putting in my parentheses here for R of t. Hopefully I won't get it wrong. I'm not confident with Khan Academy though. All right. Next, write P of t in terms of t. So my total, right? My total should be 5,000 times 1.111 t. It's my potatoes I sold, over how much money that brought in, which is, I'm sorry, this is how much money brought in, over how many potatoes I had, which is 200 times 1.1 to the t. All right, let's put that in. Parentheses on top. 1.111 to the t power over 200 times 1.1, just 1.1? Yeah, 1.1 to the t power. Should have that. It looks funky here, but let's give it a shot. I'm really concerned about this right here. I'm going to try to fix it if it gets me wrong. They gave it to me right. Awesome. All right. Another one. Deborah is filling a pool with a hose, the volume H, in liters of water coming out of the hose in m minutes is given by the function H of m equals 17.4 m. However, it's a sunny day and water is evaporating from the pool. Therefore, the volume V in liters of water in the pool m minutes after Deborah started filling is given by 17 m. Let E be the volume of water in liters that has evaporated from the pool m minutes after Deborah started filling it. Write a formula E of m in terms of H of m and V of m. So the amount evaporated should be, right, amount evaporated should be what I put in minus what's actually there now. Right, that's how much it would evaporate. How much I put in compared to how much I have now. So this should be E of m equals how much I put in, H of m, always do that with that first parenthesis, minus how much is there now, V of m, okay? And then of course I'm going to say now write it in terms of m, so H of m is 17.4. I'm not sure why I put that decimal there. Let's get rid of that thing. 17.4 m minus V of m, which is 17 m. 17.4 m minus 17 m should be 0.4 m. So let's put that in. 0.4 m. All right, I think one more. Walking on his own, the distance d in feet that Roberto can cover in m minutes is given by the function d of m equals 264 m. When he walks on the moving sidewalk at the airport, the distance a in feet that he can cover in m minutes is given by the function a of m equals 440 m. Let b be the distance in feet Roberto would travel on a walking on the moving sidewalk in m minutes if he were standing still. So let's think about this. Okay, let's think about this. The total that he walks would equal how much he walks normal plus the sidewalk. Okay, I just did this because I want to use letters that match up for a second. So the total that he walks is how much he walks plus how much the sidewalk adds. So this says I just want to find how much he would travel if he were standing still, which means I want to get rid of the W to give me just how much the sidewalk is. Okay, so let's think about this. T is this one, A of M, his total. So 440 M. Well, let's not do that yet. A of M minus how much he walks. He walks 264 m, which is d of m. So we should have A of m minus d of m. Okay. Then, what's it in terms of m? So A of m is 440 m minus d of m, which is 264 m. I'm not going to trust my brain to do this, so I'm going to grab a calculator. So 440 minus 264 should give me 176 m. All right, so 176 m is what it should be. 176 m. We got it right. Okay, so this is just putting, like, this whole section, putting these together somehow, adding, subtracting, multiplying, dividing the d of m and the a of m, figuring out which one, and then after I do that, substitute what it equals in for it, right? So we substitute this in, then simplify. This whole section that we've been doing, these I think 5 problems. Put in the function name first, figure out if I add, subtract, multiply, or divide them. After I type them in, after I do that, replace A of M with 440. So replace whatever they are, replace the first one with what it equals, replace the second one with what it equals. Simplify it if you can, get an answer. All right, good luck. Let me know if you have trouble with these. Woohoo!